what that allows to do is you start getting, it boils and so there's some water vapor in the air. And then when I cool it, that water vapor condenses back out of the air, leaving a whole lot less air molecules in the can. So then your pressure difference inside the can is a lot less, because a lot less molecules in there than outside the can. And so the pressure difference basically crushes the can. So I'll get one going here. Let me get a couple more and I'll show you what I mean. Yeah, any can. Oh, this is you have to come back. I'll do this one in a little while, man. This is a good one. This will be great. Now I'm going to put it out here. That ought to attract a lot of people. The big can. Everybody's going to have to come back. And so what I originally had hoped to do, and I had this nice little Pyrex, which is not supposed to break when you heat it, and it broke right away. But I wanted to show you that when you heat up the air, things happen. So the Pyrex goes in the ice water, the molecules will slow down and it goes in like that. I just have to show you this. And then when I put it on the hot plate, the balloon would blow up. So the molecules are moving at different speeds, and so they like to get away from each other. Kind of like if you're running down if you have to run down a football field and you're all huddled together, like in Minnesota where it's really cold, where I come from. You guys don't have it really cold out here. It's really nice, by the way, because it's cold. It was 46 below zero today in International Falls this morning. I used to teach about 100 miles, 50 miles away from International Falls, so I get the cold too. Anyway, so the molecules, when it's that cold, get really close together. And then when you heat them up, the molecules get way far apart. And so what I'm going to show you is a little difference in pressure. She's just been waiting. You ready? Because this is going to happen fast. Here we go. Wow. And that's just the air pressure that crushes that can. So, differences in pressure, what drives the weather. You ever looked at a weather map? What do you see on it? Big letters. What are the two letters you see? Yeah, but what do you see? Big weather map. It's got two letters. The two big letters. What are they? Somebody has got to have seen a weather map. You guys don't count. High pressure and low pressure. You see a big H, big L, right? It is the difference between pressures, like you just saw in the can, that drives weather. You know, from the high pressure flow into the low pressure. And so all of that starts to make our different weather patterns and our fronts. And, oh, we could go on forever, but I'm sure there's other things that you want to do besides. Anyway, to kind of show you differences in pressure from an oceanography perspective, these were actual styrofoam cups, about this big, and I put them in a dive bag and tied them onto the instrument. It's a CTD cast. We float over the side of the ship, drop it down the bottom of wherever we are. This happened to be in the Gulf of Mexico, and then pull them up. And because the pressure, it's like going swimming in a swimming pool. When you do that, when you go swimming in a swimming pool, when you swim down the bottom, what do you feel? Where do you feel it? Yeah, and kind of in your ears. Yeah, because there's a little bit of air in your ears, and so you really feel the pressure. Well, imagine a pool is about, 3 meters deep, 2 or 3 meters deep. This was 1,800 meters, so it literally squeezed all the air out of the styrofoam, and that's why the cup shrank. But it didn't crush it, did it? It just made it smaller. Why? Because pressure acts on you in all directions all the time. So you're down here at sea level in Seattle, and the pressure is 14.7 pounds per square inch. That's why I can stand with my hands out like this all day, right? There's 14.7 pounds per square inch pushing down on me, all right? Pushing down. I mean, I must admit, I'm in incredible shape for my age. But why can I do that? I can stand here pretty much all day, I think. My arms up. Because pressure pushes on me from all directions. So it's not like just pushing down on me, it's also pushing up on me too. And so pressure's equal. And that's why these cups didn't get crushed, because the same thing happens in water. It pushes on you from all directions. So it's a great amount of pressure. If we went down that deep, we wouldn't survive if we didn't have a little machine that we were inside.